Okay, so we have h equals negative 16t squared plus 48t plus 160. The above formula describes the ball's height, h, above the ground in feet, t seconds after you throw it. We want to know how long will it take for the ball to hit the ground. This is one of those classic problems involving quadratic equations. The height at the ground, does everyone agree? It is 0 feet. That's always the thing that people have problems with on this. They don't understand that, yes, they were told the height. Okay, so anyway, what we want to do is we want to plug in 0 for h, and then we're going to solve the equation. So the first thing that we want to do is we want to factor out a GCF. That thing looks pretty nasty right now. But if we factor out a GCF of negative 16, this isn't going to be too bad. So we get t squared minus 3t minus 10. Remember that we're factoring out the negative as well. From there, we want to factor the trinomial. That's going to be t and t, and negative 10 will be negative 5 and positive 2. We want our larger one to be negative. From there, we want to set each factor equal to 0. One thing to note, negative 16, do we need to worry about it? No, because negative 16 is just negative 16. All we really care about are variables. So we're going to set t minus 5 equal to 0. We can add 5 to both sides. We get t equals 5. And the other one, we can subtract 2 from both sides, and we get t equals negative 2. From there, we want to discard any solutions that are not possible in the real world. Negative 2. You cannot hit the ground in negative 2 seconds. You cannot hit the ground before you throw the ball. So when we do these, we want to make sure that we take into account real world restrictions. We're going to go ahead and eliminate negative 2, and so our final answer will be the ball will hit the ground in 5 seconds. Are we okay with that?
So why do we get rid of 16 again?
Negative 16, if you have things multiplying to 0, negative 16 times what equals 0?
0.
So does the negative 16 really play into the problem when we start talking about multiplying to 0? No. If you want, you could even divide both sides by negative 16. And then again, we're going to go ahead and rearrange our terms. So I'm going to move negative 192, I'm going to subtract 192 from both sides. We get negative 16t squared plus 48t minus 32. From there, we can factor out a GCF of negative 16. If we divide each term by negative 16, we get t squared minus 3t plus 2.
And you go ahead and
We can factor the trinomial again. We should get t and t, and we do have same signs. Both are going to be negative. Only things that multiply to 2 is 1 and 2. So we get negative 16 times t minus 2 times t minus 1. Again, I don't care about the negative 16 because it is a constant. So I'm going to set t minus 2 equal to 0 and t minus 1 equal to 0. We can go ahead and add 2 to both sides and get t equals 2. On the other one, we can add 1 to both sides and we get t equals 1. For this problem, we do want to keep both solutions as both are possible in the real world. Why do we have two solutions this time? Well, if you think about throwing a ball into the air, it goes up and then it comes back down. So in this case, what we're basically looking at is it's going to go up, hit 192, it's still going up, and then it comes back down and hits 192 again before continuing on to hit the ground at a height of 0. So if you were to look at this visually, this is basically what we're looking at. It is also possible to not have a solution. For instance, if I was throwing a ball and let's say that I wanted to know when it hit 500 feet in the air. Okay, what's the chance that I can throw a ball 500 feet in the air? Not very good. So you can have two solutions, you can have one solution, you can have no solution. Okay? So those are all the possibilities that we have for that.
The first one's technically an impossibility.
Which one?
The one where it's 5 seconds,
Why?
because it'd come out to about 480 feet with gravity plugged in. 9.8 meters per second.
We're doing feet. So your numbers are different. Okay, we're going to look at another one involving a rectangle. We have the length of a rectangular sign is 3 feet longer than the width. If the sign's area is 54 square feet, find the length and width. Again, this is technically a system of equations problem. So the first thing, I'm going to have L is equal to W plus 3 feet longer than the width. We have the area of a rectangle is equal to length times width, and it's 54. And now we go ahead and just plug in our information. We can plug in 54 for A. And we can plug in W plus 3 for L, and we keep our W. From there, we're going to do the same thing we did before. We want to distribute and move all terms to one side. So on the right side, I know this is one of those we don't see very often, but again, I just want to take my W and multiply everything inside by W. If we do that, we get 54 equals W squared plus 3W. From there, we want to subtract 54 from both sides so that we can set it equal to 0. We get 0 equals W squared plus 3W minus 54. From there, we have it in the correct format. We can go ahead and factor. We have W and W. Things that multiply to 54 and subtract to 3 is going to be 9 and 6. And we want our larger one to be positive, so our smaller one will be negative. We can set each factor equal to 0. On the first one, we'll subtract 9. We get W equals negative 9. On the second one, we can add 6 to both sides. We get W equals 6. Again, we want to discard any answers that don't work in the real world. Can you have a width of negative 9?
No.
No.
Bless you. Salud.
We get W equals 6. From there, we can plug it back into either equation. I went ahead and plugged it in for L. We get 6 plus 3 equals 9.
Length is now 9.
So the width is 6 feet. And the length is 9 feet.